Latitude Media, covering the new frontiers of the energy transition.
This year in the U.S., steel manufacturers will produce more than 71 million tons of steel. That's enough to build nearly 200 Empire State Buildings. It's a stunning statistic, but it's not surprising. The steel industry has fueled economic growth and innovation in America since the early 1800s.
Building a skyscraper, driving your car, writing a letter, or just threading a needle, you're using steel. Nowadays, our very existence depends on steel.
But it's also an industry with a massive carbon footprint. To make conventional steel, you need to combust coke, a concentrated form of coal, which helps extract the oxygen from iron ore. That chemical reaction, called reduction, is a key part of the process that turns iron ore into steel.
For each ton of steel produced this way, you end up emitting 2 tons of CO2. So it's almost fair to say that steel is a byproduct of CO2 production.
That's Tadeu Carneiro. He's the CEO of the green steel company Boston Metals. And he's a huge steel nerd.
It's always fantastic for me to discuss steel. So steel is in the blood.
American manufacturers have used coal to make steel since the 1830s, but Boston Metals is changing that.
Well, we are developing a technology that will eliminate all these emissions. No carbon involved at all as a reducing agent. So we use electricity instead. And therefore, if the electricity is clean, you take care of scope 1 and scope 2 in manufacturing steel. So it goes to 0 CO2 emissions.
Going from a steel production process that generates 2 tons of CO2 for every 1 ton of steel to a process that generates 0 emissions sounds crazy, but it's not. The key is a soup of electrolytes.
You will add iron ore in any form because the iron ore you add in our electrolytic cell, the furnace where our steel is produced, will be dissolved in an electrolyte that is a soup of oxides. So you add any type of iron ore in any form, pass electricity, and the electrons are the reducing agent. So therefore, you don't have any carbon. So that, in a nutshell, very simple process, iron ore in, electricity, you get your metal, you emit oxygen.
And so to clarify for folks, it sounds like there are basically 3 advantages to the process. The first is that you can take a large number of different sort of qualities of iron ore. A second one is that you're reducing the energy emissions because you're using electricity instead of burning a fossil fuel in order to create the heat you need. And the third one is that instead of adding carbon into the process in order to reduce the iron and then having to deal with it later on as CO2, you have a very different, effectively chemical process that you undertake in order to produce the iron.
Absolutely right.
In theory, it's simple. Electricity and iron in, steel and oxygen out. But getting it right for iron is more complicated than it sounds.
When you pass electricity and you are operating at 1,600 degrees C, you will have oxygen bombarding the anode at that high temperature. You will oxidize that. I heard more than once that it would be easier for an ice cream to survive in hell than our anode to survive in the temperatures being bombarded by oxygen.
I'm Lara Pierpoint, and this is The Green Blueprint, a show about the architects of the clean energy economy. Steelmaking makes up about 7% of global annual emissions. It's widely known as one of those quote-unquote hard to decarbonize industries. But Boston Metals innovations are pointing the way forward to a net zero steel industry that relies on renewable power instead of coal. This week, I'm talking with Tadeu Carneiro, CEO of Boston Metals, about the company's first commercial facility in Brazil, a facility that aims to reach industrial scale production by 2030. We'll hear how Tadeu's team developed and scaled a technology that is harder than keeping an ice cream cone frozen in hell.
I mean, how cool is this? The steel, the outskirts of Boston, it's not something that everyone will think it's possible. It's happening now.
To make green steel using electrolysis, the team at Boston Metals had to figure out how to make an anode that would survive bombardment of oxygen and high temperatures. The innovation was first developed back in 2010 in a lab at MIT by professors Donald Sadoway and Antoine Alenor. It was a project that had unlikely origins.
They wanted to run this process in the moon.
Sadoway and Alenor had funding from NASA, and they were initially interested in how to extend lunar missions by producing more oxygen. Iron wasn't even in the picture.
So you would get the regolith, put it in the cell, have a big solar panel, get your electricity from there, and then you will get more oxygen.
But when the NASA funding stopped, they turned their attention to metals production.
So then when that funding stopped, they said, well, what if we look at the cathode, at the metal that we form? But then they couldn't use iridium for the anode. So they had to develop another metallic solution that would be not as expensive and would be readily available. It's very simple, as you can describe, iron ore in, electricity, your metal, and oxygen coming out of the chimney, but you have lots of different solutions to get this working properly.
Step one to figuring out this process was finding the right investors.
You need to find the necessary funding, the angel investor, to move from the coffee cup size at the bench to the first pilot. Right? This happens in 2012, 2013, when the angel investor brought the finances to make that move.
Back then, the company was just a few people. When Tadeu joined in 2017, he was number 6.
Now we are 400 people in the company on this 8 years of journey that we had, and 3 very successful rounds of equity finance.
Boston Metals wasn't Tadeu's first foray into the steel industry. He has a long history with metals that he traces back to one element on the periodic table.
I am a metallurgist my whole professional life. I worked with niobium, the element 41 in the periodic table of the elements. Niobium is mostly used to make steel more efficient, stronger, and tough at the same time. But it's also used in superalloys, in superconducting applications. And so I was always associated with developing new applications for niobium, and that put me in contact of the whole metals industry, especially the steel industry.
After 30 years working for CBMM, a Brazilian niobium company, Tadeu was ready to retire. But then, in December 2016, Boston Metals made him an offer he couldn't refuse.
And then came the invitation to join Boston Metal, which you can't say no to it. I mean, it's too important and it's too cool, right?
I was gonna say, that's one heck of a fork in the road where you're choosing between retirement and growing a company into a multi-hundreds of millions of dollar company. So
yeah, it's not usual, but the beach can wait.
I talked with Tadeu about Boston Metals' coal-free, emissions-free, modular method of industrial steel production using electricity. And we talked about how the company is scaling up that technology in places like Brazil. But first, I wanted to know what obstacles he faced when he joined Boston Metals. What was the very first challenge you faced as CEO when you joined the Boston Metal team?
The first thing was to focus into these 2 businesses that we are developing with the same technology. The fundamental thing can be used for several different metal systems. So the first thing was to focus and say, look, it's one technology, let's apply for critical metals, high value, low volume metals, and also steel, right? So steel always as the high star, multi-trillion-dollar business, more than 7% of CO2 emissions and responsible for that. So it's very, very important. And the industry needs a solution for that. But the nice thing about it is that you can use the same technology and help the steel development by deploying the low volume, high value critical metals. So the first challenge was focusing, and then right after that was to find the right funding to grow the business. So I thought the thing was so cool and so important that I would get one of my friends in the steel industry who were CEOs at the time to say, I want this for me. So this, it would be right away a strategic buyout. And at that time, it was too early for them. So I visited the steel industry 9 years ago and 8 years ago, and it was too early. And so the challenge then was to find funds, climate funds, who would be willing to buy that challenge. And we were very lucky and fortunate to find Breakthrough Energy Ventures, who were the first lead investor on our first round of equity finance, joined by Climate Investments, Prelude Investments, and the Engine, the fund that was associated with MIT.
I want to dig in a little bit on your decision to focus down on these two pathways for the company, because I think this is a big issue that many startup companies face. I think often there are sort of a lot of options for what they could be doing and how they can focus what they're building in the markets that they're going to go after. And I think so often the answer comes down to just do one thing and do it well, because having that hyper focus for the company is really important. So can you say a bit more about the specific ways that you made the decision to come down to these two options? Was it really about the market value? You mentioned impact as being important to you. Was that an important thing to your investors too? Like, how did you think about which directions to pursue, and why did you wind up with two instead of one?
Well, Lara, the thing is, first of all, it can't be a distraction, right? So you have, if you are going with more than one front, they have to help each other, and it hurts to say no to an elegant project. Being a technical person, I'll tell you, but the thing is, it's very necessary. You need to lay the first egg, show that the thing works, and then you go and increase your scope, right? So why these two? Because they were not distractions. So we can deploy the critical metals, everything that is developed there, except for the inert anode that is specific for the steel. Everything else will help the steel development. So, and on top of that, you make money earlier to make the enterprise sustainable and to get to the most critical solution, which is the steel, the decarbonization of steel. So when you are developing something that is very difficult in tough tech, in this capital intensive solutions, you keep asking the shareholders for more money. So, and then every round, the question is, who is going to write the next check, right? So in our case, if you have another front that can bring resources earlier, that's who is going to write the next check. So you make the enterprise more, much more sustainable.
Okay, let's talk a little bit more about your scaling journey. So you mentioned the coffee cup size experiment. And by the way, as you said that, I was really struck that you were also talking about literally a soup of various oxides in your electrolyte. So I hope nobody confused their coffee cup with their soup cup in those early days. But that obviously was a pretty huge breakthrough, and then led to your ability ultimately to build a demonstration facility in Woburn, Massachusetts. So can you talk a little bit about the demonstration facility? How did you scope it? What were you trying to demonstrate after you had that lab experiment done?
I mean, there are lots of skepticism around the fact that we need a metallic anode that will survive very high temperatures, being bombarded with oxygen. then what we needed to do was to prove that was not true.
The first key milestone for Tadeu's team to hit to prove skeptics wrong was to demonstrate that the anode would survive for more than 30 days in a pilot cell.
That milestone we reached we delivered in 2024 when we had 6 runs that last more than a month with the first generation of industrial modular anode in a single pilot cell that survived more than 30 days. So that was the milestone. So that gave us the confidence to go for the first industrial demonstrator with 10 anodes in the cell. So now we built this 10 anode cell that is an industry demonstrator in Woburn. We commissioned that cell in February this year. This industrial demonstrator is capable of producing 1 to 2 tons per month of liquid metal. And that's the industrial demonstrator that shows that we can now go after the funding to have the first industrial cell, the first cell that will produce 3 tons per day rather than 2 tons per month. And we are now designing that cell, and if we don't find non-dilutive funds earlier, that cell will be running in 2028, which will then unlock the commercial application of the technology for steel in 2030.
Okay, so even as you're working on building your successively larger demonstrations in Woburn, you're also already in process building your first commercial facility in Brazil. So can you say a bit about what that project looks like and how it started?
Yeah, it's so that's the first industrial plant for the critical metals. So we are going to use as feedstock slags that are waste, are considered waste, and therefore has negative cost because they have to be stored somewhere properly, and that's the feedstock for our process. These slags have residual amounts of tin, niobium, and tantalum oxide. And our process can recover those values from these slags that otherwise are, just a liability in balance sheets, right? So we will have the first plant will have approximately 10,000 tons a year of ferroalloy capacity, extracting these values from slags that, as I described to you, they don't have any value today or any technology that can retrieve those value metals that are there. It is at the same time that we will have a carbon footprint that at 1/10 of the incumbent today. It's going to solve an environmental problem because you have these slags placed in stacks all over the place. So you take the value and you create value from them, and you bring efficiency. So it's not only decarbonizing. Efficiency is the name of the game today as well for us as societies. Some call it circularity, circular economy. The fact is, we are consuming today, at the pace that we are doing things, we are consuming 2 globes, and we only have one. We only have one planet. We are consuming 2 planets. So we need to bring the efficiency up. Our process does that by recovering value from what's considered waste or producing more metal using the same amount of ore. The same amount of ore, you can produce 2 or 3 times the amount of metal because our process is more efficient. So that makes a huge difference. It's not only the decarbonization.
This commercial facility is the next step toward Boston Metal's goal of industrial scale production by 2030. We'll talk about the journey to getting the Brazil project off the ground, from financing to construction, after the break. So you have a pretty strong industrial partnership to make this work. So can you say a bit about that, especially given that you mentioned that it was a little bit tricky to get their attention, that you were too early at one point. So what did you need to demonstrate in order to make this partnership a reality?
Well, now, yeah, we have lots of giants in our cap table today. So, the largest mining company in the world, BHP, the largest supplier of iron ore, Vale from Brazil, the largest international steelmaking company, ArcelorMittal. And then you have Saudi Aramco, you have Microsoft, you have the largest bunch of billionaires together, which is the Breakthrough Energy Ventures led by Bill Gates. So we are very proud of the syndicate of investors that we have. Even the World Bank, represented by IFC, is a shareholder of the company. And so, in order to get their attention, what was necessary was to show that we were delivering on the milestones that we promised, right? So as we were able to develop the technology and move the needle towards becoming commercial and an industrial level, you attract the attention of more and more investors, and we were very, we are super happy to have been able to attract all these 20 giants that are today forming our syndicate of investors. They all spread. I mean, no one controls the narrative, so they work together in a way that the company can do what's the best for the company. So that's the other important thing, having lots of strategics that work together for, to achieve the final goal. But that's it. It's delivering on the milestones along the journey that you develop and you promise.
So can you say a bit more then about the structure of the project in Brazil? So you're taking in waste as input. Are you building the plant entirely on your own, or do you have a partnership for the construction of that plant? And then say a bit about your offtake agreements and who's buying the metals you're producing.
Yeah, we are doing by ourselves. So the plant in Brazil is a wholly owned subsidiary of Boston Metal. We built by ourselves in a record time. So it's going to be 1 year to get the first module in operation, and another 9 to 10 months to get full capacity running. So very, very successful plan to build the capacity that we will have there pretty soon. And so now, in order to answer the second part of your question on the offtakes, if we wanted, we would have 100% of the production signed in offtakes today, because these critical metals, the tier one trading companies in the world, they're all interested in them, and we are very well connected to them. So we know these markets very well, and the metals we are producing are very critical everywhere. So tin for electronic applications and soldering, niobium for the steel and superalloys and very special other special applications, and tantalum for superalloys in aircraft engines, and also especially in capacitors, electrolytic capacitors, with all these data centers that everyone wants to have all over the place. Without tantalum, forget about it. People sometimes don't realize that you need a lot of mining to deploy what's going to be the best for society. So that's the case of tantalum and the data centers. So there is a huge pressure on having more metal these days. So that's why the demand is not being a problem for us to prove. So offtakes would be readily available if we wanted to sign 100%. We just don't, to keep optionality and find the best for the company, the best results for the company.
So given how strong the demand is, are these off-takers willing to pay a premium for green critical materials, or are they still pretty price sensitive?
Well, I mean, they will always present themselves as price sensitive. There is no doubt about
Well,
it.
sure, in the
Right? So, yeah,
negotiation.
of course, yeah. But the thing is, to get the material, the way you see how they are willing to get the material is that they would be willing to prepay for the material to come as a finance option in the deal. So that's another way to see how interested they are, right?
So how did you wind up structuring the financing for this plant? Was this all funded on your balance sheet with money from the company investors, or were you able to secure some of these other kinds of, funding sources from off-takers, et cetera?
We are negotiating, and we will get a finance from IFC, the World Bank, for the expansion of the plant in Brazil. So that's something that they are very interested in. We are almost finalizing the deal with them.
That's great. Very, very cool. This is a really interesting case because I think what we've seen in almost every other first of a kind plant we've discussed on this show is that the offtake agreement is critical, and you need to have as ironclad an offtake agreement as possible in order to proceed, particularly if you want to have any non-dilutive funding. But it sounds like because of the nature of demand, particularly for critical materials, that's not as critical in your case, and you're able to move forward on what's effectively a first of a kind plant and still leave some optionality.
This is correct. And there is more than one component there. So there is our knowledge of the market for these metals that we are producing first. So we know the industry and the end users because right, when you sell something for 40 years, you tend to learn something, right? So that's what happened in my case. So I look like I am 85 years old, but I am actually 128 years old. So anyway, so you tend to learn something. So the market, we pick the market along the ways as well. But then not only that, if you look at our cap table and you take ArcelorMittal, they consume more of the materials per year that we were going to produce, right? So then there is something there as well. So that's what there are many options. So as I mentioned to you before, so demand is not really a problem in our case because of these critical materials and the need to have them.
That said, I know the first sort of offtake agreement that you signed was with a company that you previously worked for, right? So do you think it was critical in that case that you had that pre-existing relationship, that they trusted you, that you've had this many years in the industry, or do you think the demand sort of carries you wherever you go?
Well, actually, that's they didn't buy the material. In that case, it helped a lot because they were our first sale. Yes, it was, but it was a project, a multi-million-dollar project, non-dilutive, to prove that the technology would work for their process. And it was a very successful program. It was a 2-year program, and that's part of the reason why the first plant that we are deploying is in Brazil, because in order to fulfill that demand, that program to use the technology for their products, we ended up building the talent, getting more knowledge about potential feedstocks in Brazil. And in Brazil, you have abundant electricity that is green from hydro, incentives in the state that we decided to build the first facility. So that unlocked lots of things. The fact that we had a relationship with them as our first sale as services, right? Using the proving that the technology worked for their product was a very successful program and helped a lot.
Yeah. Let's talk about your next couple of projects. You mentioned that you've got 200 on your list, and I presume you're not actively developing all of those at the same time. So how are you thinking about the pipeline of projects that you're developing? How many of them are you actively working on? And when and how do you think you can access significant amounts of non-dilutive funding to build these projects?
Well, we are working in different ways, taking advantage of the geopolitical situation we have today. Every country wants to have domestic production of critical metals today. So that's where we may be able to find non-dilutive capital in order to solve specific problems, being that associated to defense or to strategic stockpiles, or and for important industries that depend on specific metals, and a country has to import 100% of that metal. So these things lead to opportunities to find incentives and non-dilutive capital, right? So that's one component that will determine the next plant we will build, right? So if we have those opportunities available, we will tend to explore those, right? But then we don't need that, because these low volume, high value critical metals, our process is very profitable in getting those. So we will be able to get project finance and deploy the next opportunity. So we are analyzing which critical metals. We are not going to concentrate in only one metal. We are analyzing where these slags and waste containing these oxides with high value are available. The most beautiful thing about our technology is we don't need high concentration. We can retrieve this value from lower concentration of in these feedstocks. So and the critical metals we are targeting are nickel, molybdenum, tungsten, cobalt, vanadium, not just tantalum, niobium, and tin. So manganese is very important, and it's one of the metals in our list. So it's that's why there are 200 in the menu, because they are available everywhere, and so we are we are very busy in finding metrics to get the highest probability of success to decide on the next one.
As you're accessing this project financing, what are you finding is the most critical piece of the equation for them to ultimately say yes? Is it really about the really robust and high demand for your product? Is it critical that you're able to show them your Brazil facility and how it's operating, what the cost structure is? What are the things that ultimately are the big focus of the funders with whom you're speaking?
Yeah, the latter is a given. Now that we have an industrial plant running, we can demonstrate that there is no technological risk. The costs are there to be seen, what it is. So that's there now, so now the project finance will be the ability to get the feeds, to secure the feedstock, and then to sell the product. So those are the things that will be important to show.
Okay. What advice do you have for founders of climate companies who are getting ready to build first-of-a-kind commercial plants?
Well, I mean, I would say you need to have you need to de-risk the scale up. You have to make sure that those parameters you are scaling up, are well tested, so you don't have any surprises, right? So that's getting a proper journey in scaling up is very important. Not trying to find shortcuts or jumping the gun, or finding what's the big challenge you need to prove to the risk and prove that you don't. So you have to find out those things that people were skeptical of you reaching and showing that can be reached. So if you try to solve all the variables at once, it is going to be very difficult. So you have to isolate some of the variables, the most critical ones, show that you are able to solve, and then keep improving, right? So that's how you need to do. Attempts to solve everything in the first shot, it's, ends up looking much more alchemy than science and engineering. So
I love that. All right, last question for you. If I wired $100 million into Boston Metal's bank account tomorrow, what would you do with it?
Well, at the point that we are now, $100 million, I would build another plant right away. It's very successfully because it's very profitable. And that's the size of the CapEx that I need to double the capacity I am having in Brazil now. So at this point, that's what I would do.
No, perfect timing for you. Well, I'll keep an eye out for that 100 million. And if it comes my way,
please don't forget us.
Tadeu Carneiro is CEO at Boston Metals. The Green Blueprint is produced by Latitude Media in partnership with Trellis Climate. The show is hosted by me, Lara Pierpoint. This episode was produced by Alexandria Hare and Stephen Lacey. Ann Bailey is our senior editor. Sean Marquand is our technical director. Stephen Lacey is our executive editor. If you'd like to suggest topics or guests for the show, send an email to thegreenblueprint@latitudemedia.com. You can listen to The Green Blueprint at latitudemedia.com or subscribe wherever you get podcasts. And if you have fellow clean energy or climate tech travelers who would benefit from the insights in the show, send them a link. This is The Green Blueprint, a show about the architects of the clean energy economy.